When the breakdown of a small gasoline engine is caused by the failure of an internal part, the engine must be completely disassembled so that the cause for failure can be determined and the appropriate repairs made. In this program, we will disassemble a 3.5 horsepower Briggs & Stratton engine as an example. Here are the tools and equipment you will need to disassemble the engine. First, remove the spark plug wire from the plug and set it into its safety notch. Then, using a spark plug socket and handle, loosen the spark plug so that it can be removed by hand. The fuel tank and carburetor assembly are attached to the engine with 2 bolts. Loosen and remove the side bolt and then the center bolt. After detaching the carburetor linkage, remove the assembly from the engine. The blower housing and the pull cord starter assembly are attached to the engine with 3 bolts. Turn the engine around and remove the last bolt. Now lift the blower housing along with the pull cord starter assembly from the engine. To lift and remove the protective screen, first loosen the holding screws. The steel ball bearings in the starter clutch can easily be removed with the help of a magnet. Next, loosen the screws holding the brake band cover and remove it. In order to remove the flywheel, you must first release the pressure from the safety stop brake. To do this, loosen the brake control bracket bolts move the bracket back and then retighten the bolts. These are the tools we will use to remove the starter clutch. Position the flywheel holding tool between the cooling vanes and, if necessary, use a wood block to support the tool. Be sure the flywheel's cooling vanes are fully engaged with the teeth of the holder. Then set the starter clutch wrench over the starter clutch. Tap the wrench sharply to loosen the clutch assembly, then unthread and remove the assembly. Turn the engine upright and remove the washer from the clutch. To protect the crankshaft from damage, thread a nut approximately halfway down the crankshaft's threads. This is a flywheel puller. Its screws are designed to cut threads in the holes located in the flywheel. Place the flywheel puller over the crankshaft and allow it to rest on the nut. Start the self-tapping bolts of the puller by hand and use a wrench to tighten them. Lower the two pressure nuts. Tighten the two pressure nuts alternately and uniformly. Until the flywheel breaks free from its pressed fit on the crankshaft. Loosen the puller's bolts to remove it. Then, remove the protective nut and carefully work the flywheel free. Finally, remove the flywheel key from its keyway. The cylinder head is bolted to the block, in this case by 8 bolts. Before removing the bolts, note the position of any brackets so that you can reinstall them in the same way. Use a socket wrench to loosen each of the bolts. Then remove the bolts, bracket, and the cylinder head. In this case, all the cylinder head bolts are of the same size and length. With the cylinder head removed, the intake valve head, the larger of the two, and the exhaust valve head are exposed. Use a scraper to remove the cylinder head gasket. Now position the block so that the cover of the valve spring chamber is accessible. Remove the cover. The valve and its spring are held in place by this retainer located at the bottom of the spring. This spring compressor is used to compress the valve spring so that the spring retainer can be removed. Set one leg of the compressor so that it rests against the spring chamber's housing and the other leg between the spring and the retainer. Turn the crossbar screw to compress the spring. Grasp the retainer with needle nose pliers, free the valve, and then remove the retainer. Loosen the crossbar screw and remove the compressor. Now the valve spring can be removed. Use the same procedure to remove the second valve spring and its retainer. Reposition the block so that the crankcase cover is accessible. Examine and remove any burrs or rust from the shaft. Otherwise, the crankshaft bearing in the cover will be damaged when the cover is removed. Loosen the crankshaft cover bolts. After removing the bolts, use a soft mallet to tap the cover free. Never use a screwdriver to pry the cover loose. You might score or even crack the casting. Remove the cover. The crankcase cover serves several functions. It is the sump which holds the engine's lubricating oil. The large hole in the center provides the bearing support for the crankshaft. The smaller hole supports the cam gear. The cover also seals the crankcase, preventing oil loss. The teeth of the plastic oil slinger mesh with the teeth of the camshaft gear. Lift the oil slinger and remove it. Note the valve timing marks on both the crankshaft and the camshaft gears. For precise valve timing, during assembly, these marks must be aligned. Now lift and remove the camshaft from the engine. Since tappets or valve lifters are usually the same size and wear very little, make identifying marks on them so that they can be replaced in their original positions when reinstalled. This will ensure that clearances are not altered. In this engine, the connecting rod bearing cap is attached to the connecting rod by 2 bolts. It is not necessary in this case to mark the mating parts, since there is only one way for them to be put together. Loosen the bolts. Remove them and lift the connecting rod bearing cap from its position on the crankshaft journal. In some cases, a ridge may form at the top of the piston travel. If it has formed, it must be removed with a ridge reamer before attempting to remove the piston. In this case, no ridge is evident. Push the piston rod up until the piston is free of the cylinder and remove the piston. Now remove the crankshaft. Be careful that the threads at the end of the shaft do not scrape against either the end seal or the shaft bearing. The crankshaft is the heaviest and strongest part of the engine. Its bearing surfaces must be protected from damage at all times. The cylinder and crankcase of this engine is cast aluminum. Other engines may be cast iron. The basic components of small gasoline engines are similar regardless of model or type. That is why you can apply the skills and procedures learned here when you are taking apart other engines. Once a small engine has been disassembled, its parts must be cleaned, checked for wear, and then prepared for reassembly. These are the tools and materials used to check and prepare the parts. The cylinder block is inspected first. The block of this engine is cast aluminum. Check for broken cooling vanes and cracks or other damage to the casting. We can see that these are fine. Check the crankshaft seal in the engine block. The seal must be undamaged. Use low-pressure compressed air to clear all the block's bolt holes. It's important to be sure to wear safety goggles whenever using compressed air. Carefully inspect the cylinder wall to be sure that there are no score marks, scratches, or other damage. A telescoping gauge can be used to determine that the diameter of the cylinder bore has not changed due to wear. Insert the telescope gauge into the cylinder bore at the top of the piston's travel and at right angles to the crankshaft, and lock the gauge setting. Use a 2 to 3 inch micrometer to measure the length of the telescope gauge to determine the exact diameter of the cylinder. Record the size, 2 inches and 563 thousandths of an inch. Then repeat the measuring procedure in the same location in the cylinder, but this time in line with the crankshaft's position. And record the size. Now subtract the smaller of the two readings from the larger. This 2 thousandths of an inch difference is the amount the cylinder of this engine is out of round at the top of the piston's travel. Now use the same measuring procedure to determine out of round at the center of the ring travel and again at the bottom of the ring travel. When all the measurements have been made and recorded, you can see how much the bore has worn. Most of the wear occurs at the top of the ring travel and little or no wear below the ring travel. Check the manufacturer's specifications to be sure the wear of this bore is within allowable limits. If the limits are exceeded, the cylinder should be rebored or discarded. Now let's turn our attention to the valve seats and the valves. The seats should be clean and smooth. Badly burned or pitted seats should be replaced. Check the valve faces. The valve faces should be clean and smooth. A badly worn valve face, such as this, should be reground or replaced. If valves are to be replaced, be sure to use exact replacement parts. Valve guides sometimes wear as a result of repeated up and down movement of the valve stems. To begin a check for wear, clean the guides with compressed air. Use a dial indicator and its mount to check valve stem to valve guide wear. Bolt the dial indicator assembly to the cylinder head surface. Lower a valve into its guide until it contacts the dial indicator. Move the valve from side to side to measure the side-to-side play. The play must not exceed specifications. When the valve seats and valve faces are in good condition, a perfect seating surface can be obtained by lapping the valve to the valve seat. To do this, first place a small amount of valve lapping compound on a finger and spread the compound around the valve face. Place the valve into its valve guide. The suction cup at the end of the valve lapping tool will grip the head of the valve securely. Roll the tool between both hands. Alternately raise and lower the valve. This allows the lapping compound to flow back and forth between the two surfaces for a more effective lapping action. Remove the valve from the block. And wash the valve in water to remove the lapping sludge. Use a clean, dry cloth to wipe the valve dry and clean. Check the valve face. The resultant seating surface should be free of pits or burn marks. Remove the sludge from the valve seat and check the seat also. The valve face is now perfectly matched to the valve seat. This will assure a perfect seal. Repeat the procedure for the exhaust valve. When checking the condition of the camshaft, feel the bearing surfaces at each of its ends both of the cam lobes and the gear teeth. There should be no signs of roughness, which would indicate wear. Be sure that the compression release mechanism moves freely. The crankshaft has 3 bearing surfaces. These surfaces are called journals. Feel their surfaces. If any feel rough or scored, the crankshaft has to be replaced. Use a 1-inch micrometer to measure the magneto and the power takeoff journals. Each journal measures 874 thousandths of an inch. The manufacturer's manual contains a reject size chart. This chart indicates the limits or tolerances which must be maintained. Check the sizes of the journals against the listed reject sizes. The crank pin should be measured in 2 places to be sure it is not out of round. Check its size against the crank pin reject size. The keyways at each end of the crankshaft must not be damaged. Check to be sure the crankshaft gear teeth are not chipped or broken. So far, we have determined that the crankshaft meets all specifications and that it can be reused. But we have yet to see if the connecting rod bearing and its cap are worn. We will use Plastigauge to check the bearing for wear. Plastigauge is a thin thread-like strip of plastic. It is available in various thicknesses. Place the strip across the bearing cap and cut off a section. Carefully place the bearing cap with the strip of Plastigauge in place over the crank pin and thread the cap bolts by hand. Use a torque wrench to tighten the bolts to manufacturer's specifications. This squeezes the Plastigauge. Do not turn the connecting rod on the shaft. Then loosen the bolts and remove the cap. The Plastigauge envelope is imprinted with measurement guides. Cut off one measurement guide and use it to measure the width of the squashed Plastigauge. The width varies with the amount of clearance between the cap and the journal. By using the guide in this way, the clearance between the bearing and the journal can be accurately measured. When you are finished, remove the plastic. Even when, as in this case, the piston seems to be exceptionally clean, its rings should be removed so that the grooves in which they seat can be cleaned and inspected. A piston ring expander is used to do this. This is one of several types of piston ring expanders which can be used to safely remove rings from their pistons. The top ring is always removed first. Place the expander against the ring so that the expander tips contact the ring ends. Squeeze the handles just enough so that it can be removed from the piston. Remove each ring in the same way. Inspect the condition of the ring grooves. Each ring groove must be inspected to be sure carbon deposits, which keep the rings from seating properly, have not built up. The oil drain holes in the bottom groove also have to be clear. Now hold the piston in one hand and attempt to rock the piston rod from side to side. If you sense play, disassemble the rod from the piston and replace the worn parts. Be sure the piston skirt is free of score marks, scratches, or cracks. Always check that the replacement rings are the correct size and type. Set the replacement ring in its groove and check the remaining space with a feeler gauge. Do this in several places around the groove. Refer to the manufacturer's manual for the clearance specifications. Check each ring in its own groove. Now insert the new ring into the cylinder and use a feeler gauge to determine the width of the gap between its ends. Again, check the manufacturer's specifications. If the gap is too small, the ring may bind the piston in the cylinder. If it is too wide, the ring may not seal the piston. The first of the three rings to be installed on the piston is always the bottom ring or the oil ring. Expand the ring just enough so it can slip over the piston and lower it to its groove.